Hello everyone, my name is Dr. Yagiraj Pandey and I am Assistant Professor and Artificial Intelligence Program Coordinator at Kathmandu University. And today we are talking about the artificial intelligence, machine learning, and deep learning. And this is a one topic under Artificial Intelligence Fundamental Series of Artificial AI 101 course. Today, uh, if you are new in our channel, please follow us and we will provide you the best way, best method to teach the artificial intelligence through this course. Uh, uh, yeah. And first of all, let's discuss about the artificial intelligence. And the intelligence is actually the ability to interact with the real world, to perceive, understand, and act. It could be the human or the machine, which can interact with the real world. And if for example, the machine can interact with the real world through the sensors. It could be the light sensors, photo sensors, humidity sensors, temperature sensors, and and then try to understand the data which is recorded from this type of the sensors, and then perform its actions, what to do the next. For example, it could be the alert generations, or it could be the on and off of the different systems. For example, if you are controlling a environment inside a mushroom farming, mushroom farm, then the action could be the turn on or turn off the AC, could be the one action by the machines, right? And if such type of the intelligence is in a machine, then we can call the machine has the artificial intelligence. And the intelligence the machine intelligence could be the different level of intelligence. It could be the specific for of problem solving, or it could be the some general problem solving, right? So the intelligence is depend upon the ability of the systems to interact with its environment, right? The machine learning is the second, and which is the in the second, the machine learning we will discuss. And the machine learning is a small subdomain of artificial intelligence. And in machine learning we will try to learn the machines through the different algorithms, right? It could be the clustering algorithm, classification algorithm, or regression algorithms, right? So machine learning is a branch of artificial intelligence, and the deep learning is also a subdomain of the machine learnings, and the neural networks is also a subdomain of the machine learning. In the neural networks, we will try to design the neurons, right? It could be the Boltzmann neural networks or multilayer perceptrons, right? And the deep learning is a s- is a domain of neural networks, where basically the high dimensional data can be processed, right? We can extract the information from the high dimensional data through the convolutional neural network, or some generative networks, or some sequential networks like RNN, LSTM, right? This type of things, this type of algorithm we will basically discuss on the deep learning. Here is one of the another figure. In the left, here is a biological neuron, and in the right, is mimic to the mathematical model. In artificial intelligence, we try to develop this type of the mathematical model, which is most similar to the human understanding, right? Now let's discuss about the machine learning and the deep learning, right? In which cases the machine learning is better, or some cases it could be the deep learning could be the better option for you, right? So so, in the case of the machine learning or deep learning, these algorithms are data dependent algorithm, right? And so we call them the data driven methods. If you have the enough amount of the data, then the deep learning could be the better option for you to get the more accuracy, as you can see in this curve here. Here in the x-axis, here is the data, and in the y-axis, the accuracy curve you can see. And if you have a less amount of data, then the machine learning algorithm could be the better for you to get the higher accuracy, right? Higher performance in compared to the deep learning, right? Because machine learning algorithm basically have a less number of the parameters. That's why you can train them using the less amount of the data. So, but if the data volume is increasing, the machine learning performance cannot be increased in the similar fashion, because we have the limited number of the parameter, and if we train on some amount of the data, then there is no things to train more, right? Uh, mm, that's why the machine learning algorithm performance is some limited here. But in case of the deep learning, if you have the enough amount of data, you can improve the system performance in here is a in similar fashions, like in linearly you can improve the system performance, because if you have more data, then in case of the deep learning there is a large number of the parameter, and you can train all these parameter, and the system can get the better performance on the unseen data, right? Unseen data or test data. So the deep learning is somehow could be the better, but the data requirement is large, and also in the case of the deep learning, you need some powerful hardware to train the model, right? Like for example, GPU or TPU. But machine learning, you can you don't need such type of the high computation powers, right? Also, the execution time also could be the high in case of the deep learning, and some interpretability is also is very hard to discuss, right? But in the case of the machine learning, it can be interpretable when compared to the deep learning here. So in case of the machine learning, it cannot directly perform the learning on high dimensional data. That's why the some feature extraction is needed. The feature extraction is some special key points. Based on that, we can uniquely identify an object. For example, cat or dog. How can we how can we differentiate both cat or dog based on their texture, color, or some body size like this, right? Similarly, we try to in the machine learning, basically the high dimensional data cannot be directly processed because it's have it have the less training parameters, and also if we directly process the high dimensional data, the complexity will be exponentially increased, and even the today's hardware like GPU or TPU cannot process such data. So we try to reduce such data input using the feature extraction method. It could be some mathematical algorithm, right? And but in case of the deep learning, we can directly process the high dimensional data, and and the machine can automatically identify the the valuable features, and based on that features it can classify or find the regression points, right? So the deep learning is somehow better, and some in some problem it is the state of art method, but it needs the more amount of data, and also the data sometimes if you are dealing with the supervised approach, then the annotation also required, which could be the costly process sometime. Nowadays, the deep learning is used on different type of the problem like supervised learning, reinforcement learning, unsupervised learning. Anywhere we can use the deep learning to get the higher performance. That's it for the today. And if you have any queries, then you can comment on this video, and you can directly mail with us. Thank you very much for your patience. Thank you, and we will see you in the next video.